Welcome to the video on probability models and simulations. Before we get too far into this, I want to look at the two different types of probability. Theoretical probability is what we've been dealing with the entire time in this chapter. Theoretical probability is essentially what should happen. So without doing any trials, what should happen when I roll a die? What are the odds of it landing on certain things? Okay, the experimental is what we're going to deal with today, and that's what actually happens. So these two aren't necessarily going to be the same. For instance, if you rolled if you flipped a coin 100 times, it's most likely not going to be 50-50. Okay, exactly. But theoretically, it should be. And one thing that I do want to note is the more trials you do, the closer these two values come together. Okay, so the more trials, the better, because you're going to get closer to, you're going to move your experimental closer to your theoretical. So essentially what we're going to do today is you're going to have a scenario and you're going to look at the theoretical probability. You're going to set up a model based on that theoretical probability, and then you're going to simulate it using trials to find what your experimental probability is, what actually happens in this experiment. So that's what we're moving towards now. This slide is mainly on how do you design it. So they're going to give you a scenario like this one. Maria got a hit 40% of the time. That means she did not get a hit the other 60%. So we want to design a spinner or some kind of model that represents this. Okay, so what we did here was we said 40% of the time she got a hit. So on our spinner, we want 40% of the spinner, or 40% of the 360 degrees, to represent her getting a hit. That being said, the other 60% has to be when she got out, and that has to be 60% of the 360. Notice these fit together perfectly. That means that our values are correct. So designing this, we want to set it up so that it models the scenario that they gave. And then the last part, this part down at the bottom, is pretty important. A trial is just one spin of the spinner or one roll of the die, or in the case that we're going to use a lot today, one time using the random number generator to get one number. That is one trial. Okay, so they said theoretically she should get a hit 40% of the time. They did some trials here, so they spun the spinner, they recorded their data, and she got 14 hits out of 40, which is 0.35 or 35%, which is very close to 40%, but it's not quite. If they did 100 trials, that number is going to slowly creep towards 0.4. If they did 200, it's going to be even closer. It's going to continue to move closer to that theoretical probability with the more trials that they do. Okay, I want you to hit pause right now. I want you to complete this. And this is, again, just designing a model that will work. All right, the correct answer should be C here, because there's 4 keys. One of them wins a car, so 1/4 of this should represent winning the car. The other 3/4 should represent not winning the car. Another way to look at this is we have 1/4 of it is winning a car, so 1/4 of 360 is a 90-degree angle right here from the center, and that is exactly correct. All right, setting one up on our own here. It's a survey. There's different percentages for different pizzas. Okay, notice all of these are at 10% increments, 30%, 20%. They all go up by 10. So what we're going to do is I'm going to use 10 numbers, and I'm going to assign each of these numbers to different types of pizza. For instance, 30% preferred cheese pizza. So up here, I'm going to assign these 3 numbers to be cheese. The same way, maybe, I'm going to design the next 3 to be pepperoni, because there's 30%, and if I have 10 numbers, 3 numbers represent 30%. I'm going to do the same thing for the other ones. So now that I've designed it, okay, what I'm going to do, make sure that you've watched the previous video on how to do a random number. Our number is going to be from 0 to 9. Okay, so this is what you'll want to type into your calculator. And again, on this one, we're not going to seed anything because we're just going to each do our own simulation. What I want you to do is I want you to find the random integer from 0 to 9. It'll give you a number. I want you to just tally that. So if it's a 1, put it under this category. If it's a 3, put it under the pepperoni. These are trials. I want you to do 20 trials. So go ahead and hit pause now and do so. Okay, using the 20 trials, you can find the experimental probability. So what you're going to want to do is count up how many times the cheese occurred. So how many times 0, 1, or 2 occurred, and put that over 20. Same way with pepperoni, same way with peppers and onions and sausage. So this is finding the experimental probability. Okay, here's a really helpful slide for the Inspire and the 84 if you need a little bit more assistance. And again, that YouTube video should take care of that. And here's where you can record your data. So each of these tallies should be a trial that you did on your graphing calculator. Okay, so that's a good way to organize it. Once you hit pause, I want you to complete this one really quick. Based on these percentages, you can start ruling options out. So 20% wanted fish. That means out of the 10 numbers, 2 have to want fish. So we can automatically rule out A. 40% wanted a dog. That means 4 numbers. Okay, that means we can rule out C because it has 5 numbers down here. It's not. That's 50%. It's not the desired 40%. Continuing on, 30% wanted a cat. Here's 3 cat. Here's 2 cat. So D would be your option, your best option here. It would fit it. Another way you could do this is line up numbers from 0 to 9 and divvy them up yourself. Which one of these statements is not true? I'm just going to go through each statement and help you out here. The experimental probability and theoretical probabilities do not have to be equal probabilities. Rarely are these equal. Okay, so these definitely do not have to be equal. Experimental gets closer the more trials that you do, it gets closer to the theoretical, but most of the time these will not be the same. So that one is true. Okay, the more trials executed, generally the closer experimental will be to the theoretical. I just talked about that. That's definitely true. Previous trials have an effect on the possible outcomes of future trials. This is definitely one that is a misconception. People think that, hey, if I flip a coin 5 times and I get 5 heads in a row, it has to be tails next time. That's not the case. It has an equal opportunity. Previous trials do not have an effect on future trials. So this one is the false one. And then last one, D is theoretical probability we calculate without carrying out any experimental trials. This one's 100% true because today was the first day we've done experimental trials and we've done theoretical probability for a couple of days. So that one's definitely true. And the last part, law of large numbers, as you do more trials, the closer you're going to get, that experimental is going to move towards your theoretical and the better simulation that you're going to have. So more trials, the better. Thank you.